Hi, I'm Jared, and today I want to give you an overview of the ePrep workstation software. A typical lab workflow is where an experienced analyst usually sets up the method and then either runs the method themselves or more likely passes it on to an operator for day-to-day sample processing. So once the method has been set up, the person running the samples doesn't need to know the details of the method, but certainly needs to know how to run the sample set. The ePrep workstation is essentially a robot which uses a glass analytical syringe to move a liquid from an input vial to an output vial. So how the ePrep delivers the liquid between the two, we call this a task. This simple concept can be extended into more complex sample preparation. So to develop a workflow in the software, the user puts together a series of these tasks and nominates the input and the output containers. An example of this might be taking a batch of samples, filtering each one, then taking an aliquot to an autosampler vial, adding something like an internal standard to the same 2 ml vial, and then making this vial up to volume. So then the vial can be taken directly to the instrument's autosampler. I'm going to demonstrate this for you now.
This is an existing workflow which I created as the analyst. In this workflow there are a series of tasks and input and output files. The tasks have already been predefined to match typical lab workflows. This is a fairly simple workflow, but nonetheless, probably beyond the capability of an operator or lab technician to create. But the execution of this workflow can easily be carried out by an operator. There are many tasks to choose from in the software to cover a wide range of standard and sample preparation scenarios. Here I'll scroll through the collection of tasks that can be used in an ePrep workflow. This task list will be extended if an accessory is integrated with the ePrep, such as a vortex mixer, solid phase micro extraction accessory, or a filtering accessory. For each of these tasks there are default values in the software. Usually the user would accept these values, but they can be easily changed to suit the workflow. For example, expected high concentrations in a sample set might require more extensive syringe washing between samples. If we take the add diluent task as an example, the add diluent will add a solvent repetitively to a series of containers. So in this case we have set this up to add 300 microliters to a series of 2 ml vials. You can see there are quite a lot of parameters associated with this, like the aspiration rate and the dispense rate of the liquid, how the syringe will be primed and washed, and so on. But there are default values for all these settings, so a first-time user would just accept these and be good to go. Selecting the predefined task is really easy, and there's no complicated programming involved. It's really easy to set up the racks and containers using a graphical interface which matches the actual ePrep's deck. For example, if I want to add another rack to the deck, it's simply a matter of drag and drop. There are many racks to choose from. These vary from racks which contain large sample tubes to a wide range of autosampler racks. The actual deck on the ePrep contains interchangeable plates which accommodate the racks. The flexibility and ease of changing the racks both through the software and on the actual deck gives the user the power to create, if needed, very complex workflows. Once the racks have been set up in the software, the user will define the containers used in each of the racks, and these containers are grouped together with a name. The group is color-coded for easy identification. To complete the process, the group is then linked back to a task. As an example of this, I have defined a group of input containers which I've called solvent. The solvent from these containers will be used for the add diluent task and the make up to volume task. The number of jars can be easily changed in the workflow. Here I'll add another jar to the rack and then set the volume of all jars in this group. Once the workflow has been created and saved, running the workflow is very straightforward. An operator will check the syringes are in place and that all the containers match the tablet display. Certain containers will need a starting amount of liquid, and the operator will check this. After the workflow is started, the software does a pre-check to make sure all the syringes, racks, and containers are in place as matched in the workflow. So that's it for an overview of the software. I'll see you next time.